This one is for the geeks. A few weeks ago, we went to Atherton HQ to see how they built the incredible A200G downhill bike. 3D printing, carbon tubes, pinion gearbox. It's an incredible machine and you loved that video. However, we had to cut it down to fit it all into one short video. In this one though, it's uncut. Full-length interviews with the engineers and designers of their incredible downhill bike. So Rob, you're head of design here at Atherton. Quite a big job, a lot going on. I guess you're a busy man.
Yeah, busy and lots of interesting stuff.
Yeah.
I mean, that's the beauty of working for this company is there's so much going on at any one time. Being a company that's always pushing innovation and being so agile in the way we do stuff means that we can react really fast. So inherently, we're always looking for new things to do, looking for improvements to make to the production line or to the race bikes or whatever. So yeah, lots of stuff going on.
Okay, so today we're obviously looking at the A200G, which is Charlie's race bike for the season. It's a pretty interesting bike, not just because it's an Atherton with all the 3D printed stuff, but also because there's the pinion bolted into it and the DW6 linkage and all this sort of stuff. So where did the process start to design and think about this bike?
It really came about that Dave Weigel had a concept for his mid-pivot.
Okay.
Suspension system. That was the starting point. And the basis of the mid-pivot is it gives a optimum rear axle path, which basically translates into, for your sort of most active part of the suspension travel, it's a near vertical axle path. So the benefit of that being that your wheelbase isn't changing as you're pumping into a corner, so the grip therefore is maintained evenly between your two tyre contact points. Yeah. So that was the starting point. We always knew that would take the existing race bike and take it to a new level. So it was then a question of how do you actually execute that and engineer that, because there are some practical problems with literally how you squash that mid pivot in the proximity of a bottom bracket. Okay. And obviously if you've got a regular derailleur drive system, you've got a 32, 34, whatever tooth chainring, and you just run out of space. So the first thing was, let's do this mid-pivot because it's got all these suspension performance benefits. Second was, how do we package it? The gearbox, because it's over-geared, allows you to use much smaller sprockets. Right, so it means you can fit it all together without having to do a dual idler system or something else that brings weight and complexity and potentially reliability issues. So that was the sequence of events in terms of performance and then packaging. And then obviously the gearbox allows you to use a belt, which brings its own advantages in terms of reliability, durability, and actually, against quite a lot of common misconception, you do actually get efficiency gains at that peak performance point of a finish line sprint.
I'm imagining brands like Pinion and Gates were quite keen to potentially work with you guys. How did that conversation all happen?
It happened very organically, really, because it very quickly became these were the obvious partners to work with to execute this vision of what we wanted the race bike to be. We didn't have a lot of time to do it. And this was literally, the conversation started around August last year.
2024?
Yeah.
Wow.
So we're like, right, let's do this. I mean, the conversation started 6 years before that.
Sure, the concept of let's make it.
Yeah, and the desire, Athy, Brownie and I regularly talked in Athy's caravan, back in the sort of early days that this would be a cool thing to do. So it was something we always wanted to do.
The gearbox bike.
Yeah. And then this was an obvious way to realise that. And then the opportunity, the stars just kind of came together. So we were like, let's do this. Let's make it happen for the 2025 season. Yeah. We knew it was really ambitious because obviously we weren't going to be able to do a lot of iterations with prototypes to get ready for the season, and obviously give the racers enough time on the finished bike to be up to speed by the first race. So there was always a risk, but we basically got everyone together and just did it as a genuine partnership. So right from the start, we had obviously Dave Weigel, who's absolutely integral. We, calls with Dave, the guys from Pinion, guys from Gates, and obviously the racers as well, to get their feedback, because we knew we were creating a very different bike. Yeah. So getting all those people working together just to figure out little things like what gear ratios are we going to have. You're going from a cassette to a gearbox, you're not going to get exactly the same gear ratio. So do you aim it to get the same gear ratio for the finished sprint or for the start, or all these little subtleties? And then you're working with standard belt lengths, so it's much more restrictive than just a chain where you can change how many links you've got. So there are all these little details to figure out. So work very intensively, say with all parties, and the riders involved very much, because they obviously, it was a big leap of faith for them. We're taking a bike that Charlie's literally been world champion on, and saying, no, we're gonna get rid of that, and we're going to do something completely different, but you've got to trust us.
Yeah, with a system that he's never ridden before, presumably.
Exactly, yeah. I mean, a lot of news, so belt, mid-pivot and gearbox, so a lot of new stuff. And then all the chassis stiffness changes that inevitably are going to come from that new structure.
Okay. I mean, do you think this is a project that you could have done had you not worked in the way you do with 3D printing and lugs and all that sort of stuff? Could you have turned it around in 6 months, 5 months?
No, I think fundamentally the manufacturing process we use and the way that we work as well, where we have such a collaborative team, say where Dave Regal is an integral part of our team. You know, the riders are an integral part of the feedback process, and then we can react. We can prototype the designs in a way that is completely uncompromised. So our prototypes are also how we manufacture the finished product. Yeah. So there's no loss of subtlety between making an aluminium mule and then a carbon cast. Like that's one of the real beauties. You can refine the prototype to the nth degree and then know that the production one will be exactly the same. There's no interpretation you're having to put between the two. So no, I think the way that we work and the process we meant that we could do this. And I don't think there's any other way we could have.
So I think, if I understand correctly, the bikes were sort of delivered just before Christmas to Charlie. What was, from sort of coming off the computer with a design to actually having a physical bike, I'm guessing that bit of the process from let's download the files and put it into a printer and having a bike is actually quite a short one.
Relatively speaking. So the timeline, when we started discussing it kind of August time, Dave sent me his preliminary kinematic layout. So he basically sends a 2D drawing saying this is where the pivots need to be. So I think he sent that on about the 20th of September. So we then had about 2 months of turning Dave's kinematic into a structure that is strong enough, B, can be manufactured, but also has as close a stiffness characteristic to the existing bike. So we used the existing A200M as our benchmark. Let's get as close to this as we can in both kinematic and stiffness. So within 2 months, the design was sort of frozen in its first iteration. Obviously, you've spoken to Will about, or you'll speak to Will about all the FEA work to refine that. And then it takes around about 2 weeks to print, heat treat, fettle and machine. Okay. So going from actually having a file that's printed to something that we can bond together. Goes through those 4 steps. And to accelerate that, we work obviously with Renishaw very closely. So for a lot of our development builds, they will actually print it themselves because they have heat treatment in-house, so it just takes 2 weeks out of the lead time.
And for the 2025 season, if you look at the team rosters, there's I think 4 elite World Cup teams racing Opinion with the Gates carbon drive. For a couple of seasons now, Gates have had this €100,000 prize for the first person to win an elite downhill race on their Gate drive, on their carbon drive. How much of an influence has that played? Maybe with yourselves, but also do you think as the market as a whole, is that why we're starting to see some teams racing it, or is it just because the system's better?
No, I think undoubtedly, obviously, it's a big marketing gesture, right? And it's worked. But I think the technology was in the right place. It was ready for that, and I think to their credit, they obviously had to do something that got people's attention. Gives it that push over the line, and obviously World Cup. The World Cup racing field is a perfect place to showcase new technology. Yeah. But I mean, personally, we've been talking about this for years. We've been waiting to do this. Yeah. So then, it doesn't take much then to just kind of go, right, go on, crack on and do it.
Sure. In terms of the pinion drive, do you feel that that's, people have been talking, whether it's on the forums, in comments, or just in the general sort of chatter, about gearboxes in mountain bikes being the ultimate solution. Do you think they work better in a downhill setting where weight is less of a consideration? Maybe, on a cross-country bike, if you're pedaling up a hill for 20 minutes, maybe that loss of efficiency is not going to be great. But on a downhill bike, maybe it doesn't matter if you're just putting a 2,000 watt sprint. Does it feel like the best place for this technology right now?
Yes, it's certainly a sensible starting point. I mean, as an example, Charlie was putting 500 grams of lead into his bottom bracket. So you're putting weight where the riders are looking for more weight anyway, and you're taking weights away from your rear axle. Yeah. So you're only improving the kinematics of the bike. Yeah. So as you say, downhill, obviously there are some compromises with a gearbox bike, but they're very quickly lost in the noise of a downhill run.
The heat of the battle, actually, maybe a few watts here and there doesn't matter.
Exactly, and the benefits of having a system that you just know is going to work. B, obviously all the shifting options you've got, especially with a new smart shift system where you can shift under load. It's a no-brainer. Yeah.
Is this product or this sort of technology something that Dave Riegel, for example, has been excited to work with, do you think?
Dave said this is the most he's been excited about a project in a long time. Yeah, and he was. It's really important to be clear about his involvement. The day one of what we do in terms of actually executing the design is taking his drawing, and if that drawing isn't good, then you're stuffed. Yeah. And as I said before, there was a lot of very particular challenges with how you fit in a tensioner, how you work with the standard sprocket sizes, belt lengths, etc. And also not knowing exactly what, we built as much adjustability into the first prototype as possible, so to allow us to shift around with the gear ratios, change the geometry, so building a kinematic that's able to adjust to all of those changes that we wanted to do down the line, and getting that right first time was an incredible achievement, and that was down to Dave and him working so closely with Ryan from Gates and ourselves, obviously, just to take all our experience of packaging and building AM bikes.
So would you say the whole packaging thing, what have been the biggest challenges to building the bike from an engineering point of view?
Yeah, obviously the space required to put a gearbox in a place instead of a bottom bracket. Yeah. And then the impact that has in terms of the size of the mounting lug, which isn't just a case of making a larger part. The additive manufacturing process in its own right is a real dark art, and as a basic rule, the larger the part is, the more trouble it's going to be. Right. Because the bigger it is, the more it's going to distort. Yeah. So that was a massive issue. But then from a structural point of view, suddenly you with the mid pivot, your idler, all your forces are coming into the frame through a very different positions. So the seat tube is suddenly carrying a lot more force from the belt. It was, although we had a lot of common elements to build on from all the bikes we've done to date, there was a lot of new stuff. So the fact that the first prototype actually is what is going to be being raced
at Hardline
is awesome. Yeah. No, that's a huge testament to the whole team.
I imagine you're going to sort of settle on this for a little while, but and develop version 2, version 3, whatever it might be through this season. But do you think we're going to be seeing this sort of technology, that integrating the pinion into the S170 or a carbon? Where's it going to go?
I think, obviously, as you say, we're going to learn a lot over the next 6 months. But personally, I want to see an A170 with a gearbox and belt. Yeah. I think that makes complete sense. But yeah, we'll see. I mean, it'd be great to offer a gearbox and a traditional derailleur drive system. As the way that we manufacture, we can offer multiple lines and lots of different products because we don't have to carry all the stock because we manufacture to order. So we've got that ability. But yeah, I think we're going to know a lot more in 6 months. Yeah. And in the meantime, we're going to be trying out, we've got the 9-speed gearbox that we're already putting into a 170 version and just
I guess that's the
trying
thing.
Stuff.
Pinion offer, was it 3 different speeds.
Yeah.
What was it? It's 7,
6,
9, and 11?
12.
6, 9, and 12. Okay, there we go. So it obviously has that utility across a wider range of bikes.
Yeah, and the packaging envelope certainly for the 6 and the 9 speed is exactly the same.
Right. Cool.
Yes, we'll see.
Yeah, exciting stuff. I mean, obviously, yeah, the bike is possibly one of the most hyped in the pits this season. Everyone is super excited to see it out there. So, yeah, it's going to be a really cool sort of early season of racing just to see how good it really is.
Yeah, for sure.
And obviously, Charlie's kind of handy on a bike.
Yeah, to see. I mean, he's so excited about it. He's never been so directly involved in the whole process, the development process, and you can just sense there's an excitement there and a hunger to get out and show what it can do.
Yeah. All right, so I'm with Will. We're here in Atherton's design facility, and you've got some fancy things on your screen. What is it that you're doing here?
I'm usually in charge of sort of structural analysis on the new frames. So at the moment we're looking at the FEA analysis of the Gearbox bike, which is something we do with all of our bikes before we make the first prototypes to make sure that they're sort of safe to ride before we do any on-track practical testing.
Put the riders on the bike in Dovey.
Yeah, we tend not to just chuck them on it without knowing if it's safe or not.
Okay, wicked. There's obviously some complex stuff going on screen. It doesn't really make much sense to a layperson like me, but what is it that we're looking at here?
So what we have on the screen now is the stress analysis for load case 1, which for us is a sort of heavy bottom out on the pedals. So you can kind of see where the stress distribution is in the frame and where this is the final result. So everything is kind of okay now, but we use this to sort of add bracing and material where it's needed to keep the frame from...
So where the red bits are, is that where you want a bit more material, for example?
Yeah, so typically those red areas are where we would add more. These are still actually acceptable. They're sort of the peak stress that's shown here, but this is the frame as it is after sort of several iterations of this, where we've made minor tweaks and sort of reduced the stress in those areas.
Okay.
So this is the race bike as it is now. So it's safe to ride and we're happy with that. But, you know, if I don't have the results in front of me, but previous versions maybe would have had bigger peaks in stress that would have been not acceptable for us.
Okay. And so is this all calculated by like computers, or have you gone in and sort of worked stuff out? And is it based upon physical things that you've made which have been broken, or is it a complete computer analysis of the design?
Yeah, so this is a complete sort of computer analysis of the design. So we make the CAD for the lugs, and then I can show you the results of this. Essentially, you give those lugs to the computer and tell it how to create them, and it creates a little mesh of thousands and thousands of little nodes and triangles. And that is what is then analysed through the stress analysis. So you can see through this orientation. So it splits it into these little triangular nodes, and then you can essentially apply a load to one, and it will calculate the stress as it moves through the frame. So you've got fixed points at the sort of wheels, and then.
And in this sort of FEA, is this somewhere where you can sort of work on the flex of the frame a little bit? Can you introduce design so that it flexes a bit more in a corner, for example, for traction? Or?
Yes, exactly that. So we have a stress plot, which will help us sort of define whether the material is able to cope with the forces that are being applied. And then you also get a displacement plot, and you can use that to tune in exactly how much the frame will flex as a whole through a load. So typically we'll sort of start by getting that sort of stress analysis correct and making sure that the lugs are sort of safe and you won't get any fatigue. And then after that, we'll tune in the amount of deflection at the sort of axle and the contact patch. Particularly if you're like tuning in those corners. Yeah. And so on the Gearbox bike, you'll see it downstairs. We've got these
the little
stiffness plates. So what we can also do through the analysis is kind of benchmark exactly how much stiffness each of those plates will add and then what orientation. So that was all done through simulation. And then there's obviously the real world testing will never be perfect to that simulation, but it gives you a really good benchmark for roughly what kind of change you can expect when you add these different bracing plates.
So what we're seeing on screen, is this basically what you'd see even before anything physical's been built?
Yeah. So this existed, several weeks before we actually had lugs in the building.
Wow.
Yeah. So this is what we'll come up with a design that looks, I mean, it will look similar to what is on the screen now after Rob's sort of come up with that first design. And then it's a few weeks of sort of back and forth iteration to sort of turn it from an initial concept lug into one that is safe that we can produce.
Okay.
And ride.
Cool. And then you go back through the process again with some feedback.
Yeah. So I'll generally, I'll load it into the simulation and run it, and then I can recommend changes and highlight areas that are peak stress and feed that back to Rob, and he'll make another version of the lug.
Cool.
And yeah, rinse and repeat until we're sort of happy with the results.
And how many would you expect to do before you get sort of the ride, the race rideable bike?
I think it really depends on it. So on this one, I think it was probably a few more rounds than normal. I can't remember exactly how many, but a good dozen or so.
Sorry, a dozen.
Yeah, a dozen.
Okay.
Yeah. So it really depends. Sometimes that initial form of the lug is closer to being acceptable than others. And I think with this one especially, there's a lot of new forces going on, particularly with how we're interfacing with the gearbox and the sort of stiffness requirements that you have for a belt drive. So there was a few more iterations than normal, just to make sure we were completely happy with how that was all going to operate.
So all the different colours on here, that's because the bike's being loaded, say, through a corner, for example. Where do you get all the loads from? How do you know how much force is going through a pedal when you're going through a corner?
So we now have a set 4 load cases that we use, which kind of encompass a broad variety of riding scenarios, but they were initially developed to capture a sort of set of on-track testing that we did with strain gauges on a bike. So we sort of found what the max loads were through a sort of wide variety of riding scenarios, and then we've developed these 4 load cases that kind of broadly cover off the worst case of all of those multitude of riding scenarios.
Okay, so it's unlikely that any of those are going to be exceeded in a race run.
Oh yeah, definitely not.
Right.
I think the load cases have got a bit of a safety factor in them as well, so they're definitely sort of worse than average riding stresses.
Cool. Okay, we're here with Scott at the Renishaw Renam 500Q. It's a quite fancy bit of kit, but Scott, tell us a little bit about yourself and what is this thing? It's not quite your normal 3D printer.
Yeah, so I'm a design engineer here at Atherton Bikes. So I work quite a lot with the AM side of things, with Jamie, who runs the machine, and Andy as well. So kind of the 3 of us look after the AM side of the business. And this is a laser powder bed fusion machine.
Okay.
So it's not like your standard kind of hobbyist 3D printer. So it's not printing in plastic, it's printing in titanium.
Yeah.
And instead of, for example, your standard hobbyist 3D printer will build up, so it'll kind of extrude a layer of plastic and then move up as the part progresses. This kind of almost works in reverse.
Okay.
So we will load in a tie substrate.
Yep.
So this is kind of the starting point of the build, and this is what the parts then get printed onto.
Yeah, okay.
So the plate will get loaded into the bottom of the chamber, so you can kind of see the bottom of the chamber there. And as the print progresses, instead of the extruder on a hobbyist printer kind of working away from the part, the parts are essentially moving down.
Okay, why is that?
They grow. So that's to keep. So this has got an optical module in the top of the machine here,
right?
With 4 lasers, and that distance between the optical module and the plate needs to remain, or the lasered layer needs to remain the same.
Okay.
So as you kind of progress and create layers, the coater rail is going to the back of the machine, collecting a dose of powder, and then it works back to the front of the machine. And then the lasers can work across the build.
It leaves a fine layer of titanium filings or dust, or?
Yeah, so it's a titanium powder, so that's between about 15 and 53 microns.
Okay.
So a very kind of fine powder.
Yep.
And it lays that down in 60 micron layers, and then the plate will lower by another 60 microns, lay another layer, and then it kind of keeps working through.
Okay. So the lasers come in, they hit the powder, they melt the powder onto itself, and then that's that, and then it's done, another layer on top, another layer on top.
Yeah, exactly.
And you end up with a few thousand layers making up one of these.
Yeah, so anywhere from kind of about 2,500 layers per build.
And how long does, I mean, this is the downhill one with the pinion mounting on there, and this is quite a special one for you guys. You ain't going to be doing this on the daily, but a normal one, how long does it take to make a, I don't know, A170?
Yeah, so that takes around 18 hours at the moment.
Okay.
So we kind of, it means that we can rotate daily as well. So every day we can print. And you kind of got a good cadence with that.
Yeah.
So yeah, that takes about 18 hours start to finish.
And this one?
This one is probably half again. So you're kind of like 25 hours plus.
Okay.
I can't remember the exact figures for that one, but it's kind of a development bike for the race team at the moment.
Sure. I mean, I guess you can just go and buy another one of these anyway to speed the production up, because
they're only 600k. So yeah, so they are £600,000. So pretty serious bit of kit. Yeah. But gives us a lot of freedom. So
when you've put this layer of powder on, it doesn't all get used, obviously. This comes out looking a little bit different.
Yeah, so like I say, the plate's working down. And when you finish the build, essentially this whole height of the build will sit below the chamber floor. And all of your parts will then be surrounded by powder. So essentially one large cube of powder. And then we can basically bring the build up and kind of uncover the parts. So you're almost like digging away around the parts. And all of that powder then goes down into kind of two grates, front and back. The powder works down into the hopper, and then the next build uses that powder.
Okay, so you're not this isn't waste powder then?
No. So everything that you see here, aside from these supports that are kind of anchoring the parts down, will obviously go into the bike. And then any powder that surrounded this part but didn't get melted to create it will just go back into the next build.
Is there any other, you know, like when you solder, you use a bit of flux to help everything melt together. Is there any sort of flux type material in the powder, or is it straight up titanium? Or?
So this is just titanium 64 powder, so it's grade 23 powder. What there is kind of during this process, and you can kind of see it with the way the kind of the plumes work away from the melt pool. You have got argon running through. So this is kind of like essentially an inert chamber, and then the argon is taking away any kind of plumes of smoke and any debris away from it. So your lasers are always working through a totally kind of clean environment, and it's never kind of getting distorted, if you like, by the plumes.
When this comes out of the machine, is it always perfect, or do you get, you know, like when you sort of things get hot, they distort things?
Yeah, so there is a level of distortion. So I guess with any of these parts, we've been working with them for quite a long time. So we've kind of understood exactly how to create forms that work well with that. But yeah, there's definitely a little bit of inconsistency sometimes. And that's kind of part of the process, I guess. But we create and design the parts to kind of work with that and that not affect anything. So yeah, most of your parts will come through looking very similar. There maybe be some of these sort of lines here will be slightly different between builds, as the kind of heat distorts the part slightly. But it doesn't affect kind of the function at all. Just means that each one's kind of unique in their own way, I guess.
One thing that the bike industry loves is aircraft grade titanium.
There you go.
Is that, what is that?
And it's basically a very high grade of titanium. So grade 23, for example, has quite a low oxygen content. As opposed to, for example, like a grade 5 powder. It's very similar, but with higher oxygen content. So, for example, a lower oxygen content generally gives you a less brittle part, basically. So the kind of fatigue strength of the part, it can deal with more cycling. So we also heat treat the parts to increase that elongation as well. So it means that theoretically these bikes will never fatigue, so they have an infinite life. So they've kind of been designed with that in mind. So yeah, this is kind of the current layer that we're working on now. So we're 336 layers into this build. So as you can see, that's basically a cross section, 336 layers up on any of these build plates. And then it works up, and you'll see there's kind of very tiny changes in
incremental, isn't it?
So it's only, like I said, it's only 60 microns changing in height between each. but then obviously as you skip further through the build, you'll see much more drastic changes as you're working up through the parts.
Yeah.
And then as you keep climbing up through the layers, you'll see some of the parts start to disappear. So obviously the smaller parts are finished printing, and they're kind of then just sat on the plate until these kind of larger parts finish later on.
Cool. And what's the story then with the lasers moving across in the way they do? Because the bar goes that way, the lasers go that way. What's going on here?
So this is probably quite a good screen actually to explain that. So each of these colours represents one of the lasers.
Oh.
So we've got 4 lasers in here.
Right.
So you see laser 4 is purple, laser 1 is green, and so on. And so each of them are working in what we call swim lanes. So they're working from the left-hand side of the bed over to the right. And that's done in that way to kind of go against the gas flow. So the argon is going in the opposite direction, and therefore any part that you've just created, so you've just melted this area here, all the plume and debris that comes off that is getting taken left, and then it can work right into really nice clean air. So they kind of work opposite one another for that reason. So here we've got kind of a diagram of what's happening in the chamber. So you'll see this plate here, surrounded by these 4 bolt holes, is essentially the substrate plate. And then at the front here is your coater rail. So you'll see in a second, once this layer is finished lasering, which is just about to go to the back. So that's the coater rail going back for powder.
Fills up here.
Fills up, lays another layer. And then it works around through the lasers.
And now
again.
the lasers are going that way. And the argon's going that way.
Exactly. Getting the hang of it. So then at this side, this is the elevator. So this is your Z axis. So essentially the height of the plate. So you see now that dotted line represents kind of the first layer, if you like. And as we work down, so like I say, now we're on maybe 340 now. It's just moved down 340 times by 60 microns. So that's the current position. And when we finish, the plate will maybe be somewhere down here. And then you'll have the parts surrounded by the powder on top of that.
What's the biggest thing you've ever 3D printed?
In all honesty, probably this. Which is a lot of kind of what the challenge of the manufacturing of that came down to. So if you look at it top down, you've basically got the envelope of the part. It's basically flush with the sides of the plate. So obviously it can't go out with that, otherwise it won't be able to go down in that Z axis. So yeah, this is for us probably the biggest part we've ever printed. So for this, the timeline's a lot of it, the design flexibility. We've been able to turn this around in a matter of weeks, which is just, I guess, impossible with most other manufacturing techniques. In terms of for our kind of consumer products, we can offer 22 sizes, which we kind of, obviously there's a time commitment to actually creating the physical lugs in, or I guess the virtual lugs in CAD. But in terms of actual kind of any fixturing or molds like other manufacturers might have, that just doesn't affect us. So we're totally free to make the exact size that we feel will fit an exact customer. So yeah, we do custom sizing as well, so we'll actually make to the millimeter what size do you want. And then that will just be, instead of committing to a mold for that, we're just committing to one build. And that's it. So there's kind of no long-term commitment to that design. So this is the next size of the race bike. So it's literally just arrived literally today. So this is very similar to that one there, but just of a different size.
And I'm doing the unboxing.
Yeah, you crack on. So this is the first one we've had through from Heat Treat. Cool.
Oh yeah.
There you go, there it is.
Don't drop it, Tom.
There you go.
Wow, there we go.
So you see most of this is very similar to this one here, but some of these front end parts will then be size specific. So this one's a slightly shorter reach to give the race team more sizes to kind of play around with and test.
So that says 455. Is that a 455 reach?
Yeah, there you go, it's just 455 reach.
Cool. PW6, 455. So this has come back from the heat treatment and now it's going to go to the fettling. All this chopped off, smoothed off. Process continues. All right, so we've been in the 3D printer, we've got our big chunk of metal, and then we take it to the fettle room, which is a great name for something.
Yeah.
Is this for fettling with things? What are you doing here?
So this is essentially where the plates with all the parts and all the supports are taken down to the individual components.
Okay.
And then those components are taken through to kind of a near finished state, ready to have any machine features kind of added and all the key tolerances added through machining.
Okay, so taken from like rough to hopefully not so rough.
Yeah, so I guess here's an example of something similar to what we were just looking at there.
Yeah.
So for example, this here is the seat stay brace. So as you see, there's kind of all these different supports that are anchoring it down to the plate, holding it in position there. So they get removed. So there's kind of an air chisel process where this is kind of removed from the plate, but you still end up with all these supports here.
Yeah.
So you see the kind of essentially the witness marks of where those supports were contacting the part. So obviously those all need to get removed. So there's various kind of processes in there that we go through to essentially take that back.
Okay.
So these are hand finished then.
All right, that's a lot smoother, right?
Yeah. So all your witness marks are gone. It's a very clean surface. The guys are really good at kind of giving a nice detail to things. But obviously at this point you'll see kind of the contrast between it. Obviously you don't want to leave it like that. So once these parts are fully finished in that same way, so you'll see this still needs a bit of finishing in here from supports. Once that's all finished, it will get shot blasted.
Okay.
So you see from there to there, this is just a totally uniform finish. So you can no longer see kind of a transition between those different processes.
Yeah.
And that kind of uniform finish is good from like a stress perspective as well.
Okay.
So keeping everything
safe.
Yeah.
And then it goes to get heat treated.
So this is all after heat treat.
That's been heat treated on the block.
Yeah, so if you imagine, so these parts are coming through on the plate from there, and before they even leave that room, they get boxed up and sent out to heat treatment.
All right then, so now we've done all our fettling. Is it just a case of sticking some carbon tubes in there and sending it off to the people put into a bike, or?
Yeah, so not far off.
Okay.
But so even once these parts are finished fettling, all the kind of interfaces and the critical tolerances are all kind of machined in.
Right.
So we print, like these head tubes for example, we print the head tube with like machining stock.
Right.
So there's a small amount of extra material printed into that area that can then be machined back.
Right.
So that process has a much higher level of precision.
Yeah.
And you get a much kind of cleaner surface finish, for example. So here's a machined head tube. So that's ready for your headset cup, and the tolerancing on that is really tight.
It's not someone with a file just...
No. So that's a CNC machine.
Right, okay. And that's off-site, is it?
So yeah, our machining partner is just down the road.
Okay.
So we work with them with these parts, but not physically in this building.
Sure. Okay. And then you get it into quite a nice finished state, and then it's on to bonding.
Yeah, so these then come back from machining,
right?
And they're really thoroughly clean. So they go through like an ultrasonic cleaner.
Okay.
And then they're doused through with IPA to clean out all the joints and make sure everything is free of any contamination. And then they're bonded. So then they're loaded onto the jig, filled with glue.
Okay.
Tubes are installed, etc.
So bonding is what we'll think about next.
Yeah. So bonding happens just in this next room along here.
Jim's race bike.
Where's yours, Tom?
It's coming, it's being built. So this is a very clean room because this is where the bonding takes place.
Yeah, so this is the bonding room. So we can't go in and out of there.
Yep.
So that's kind of totally free of any contamination.
Okay.
Everything that goes in and out of that room is clean.
Okay.
So once the lugs come back from machining, the ultrasonic cleaner's in kind of a secondary room at the back. The lugs get fully cleaned before they even enter here, before they get a final clean again.
Right.
So everything is totally immaculate before it makes its way onto the jig.
Okay. And it's obviously not Pritt stick in there. What kind of materials are you using to bond the carbon tubes to the titanium lugs?
Yeah, so it's a toughened epoxy basically.
Okay.
That's used to bond them. So the lugs kind of all get loaded up onto the jig. They can then get filled with the adhesive.
Okay.
So we looked at those kind of double lap joints earlier. So that is like a clevis that can be filled with adhesive.
Right, okay.
And then the tubes get plunged into that again.
And how strong is that joint? Like, is it like unbelievably strong, or is there a bit of like flex in there, or like?
It is unbelievably strong.
Right.
Yeah, so the double lap joint itself, obviously it's a clevis as opposed to, I know some other folk kind of do single lap joints, for example. and this is kind of a big step up from that
Right.
in terms of strength.
Okay.
Especially so with that double lap configuration, you can't kind of peel the tube away from the lug because it's surrounded by another wall. However, in shear, so pulling the tube directly out, adhesives are very high performing.
Right, okay.
So you can kind of isolate the specific scenarios where glues or adhesives are very high performing and make sure that's the only thing that the glue is experiencing.
Okay. How long does the glue take to dry? Say, we can do the lugs in 24 hours or 18 hours.
Yeah.
Similar time or?
So these bikes kind of stay on overnight.
Okay.
And then they're left to cure for kind of a bit longer. We can't really go into all the details of the specifics of that.
Sure.
But yeah, they're kept on the jig until they are kind of sound as one unit. They're not going to flex apart.
Yeah.
But we wouldn't then load them, for example. So yeah, can't go into all the details.
No, that's all right. And then they're left to hang to fully finish off.
Yeah, so they finish curing for a bit longer, and then they go off to get painted.
Cool.
So our painter is local to us here, and we work with him on all the frames.
Right.
So they go from here away to paint, and then back here again to get built up into a bike.
Over there. So Luca, you put together all of the Atherton bikes that go out of the workshop for all the customer and stuff, but also you work on the prototype bikes and the team bikes a little bit.
Yeah.
What insight does that give you when it helps to design the bikes?
So yeah, at Atherton Bikes, I'm in the best possible way, but the last link of the chain, so everything comes through me. So all the last checks, paint, clearances, and if anything in bond needs to be just checked, it's up to me. So yeah, when I started working here, I started at serial number 250, and we are now past 700. So I pretty much have had ends on every single Atherton bikes that went out, A and S as well. So yeah, with that kind of body of experience in a way, like when it comes to something, the new prototypes, that being aluminium or carbon titanium, I really enjoy that kind of lending a hand to the design team that it's all well and good in theory, but then until things are checked, like in real life, it's a different story sometimes. Sometimes it's perfectly good, but yeah, having that kind of insight is really nice.
So is that things like cable routing and all that sort of jazz? Or?
Yeah, so the cable routing on the latest 200G, for example, we spent a bit of time on the routing of the rear brake hose and how to make it work with the mid-pivot new kind of kinematic side of things. Routing of the belt, tensioning, how to attach it, how to especially keeping in mind for this first few iterations, it will be like a race product exclusively. So keeping in mind what the race mechanic then would actually need to do and how fast he will need to do it, how fast he will need to access certain parts. So that's a few parts have changed, let's say, since the first iteration, which is, it's just really exciting to see and see it so fast coming through and changes happen really quick.
So I mean, we've seen the race mechanic here today, so I guess it must be quite a close relationship that you guys have.
Yeah, definitely, I helped in the first development while Ben was busy with other projects and being away. But then, there's kind of like a constant communication through development side of things to actually pass on. Of course, Ben is the one that will actually have full-on access and hands-on during the race. So it's always good to have his input and pass on whatever we find during the development stages.
All right, Charlie, so it's mid-January. How long have you been riding the bike? Because I'm guessing it's pretty new.
Yeah, it is fairly new. I got the bike on the 21st of December.
Okay.
So it was a little early Christmas present for me. But yeah, I've managed to do loads and loads of riding on it. And yeah, it's feeling really, really good.
Yeah. Is this like V1 of the bike, or have you had a chance to sort of feedback, and have there been any material changes to it?
No, so this is literally the only bike we currently have. I mean, we sort of sat down with the design team and the engineers and everyone and sort of planned out the map of what the process of the bike's going to be. So we sort of cut it down into phases. So like phase 1, phase 2, phase 3. So at the minute we're in phase 1, which is just like troubleshooting and making sure everything works right.
Yeah, okay. And how long ago was it that you've sort of heard that this was going to happen? Has this been a discussion for a long time, or were they like, we're doing a Gates drive?
So there's been chats of it for, well, over the last few years, really.
Okay.
But it properly come into light probably middle of this last year.
Right.
That's
So
when
only
we
like 6
started
months
chatting.
ago.
Yeah. So yeah, the boys have done a pretty incredible job to literally design a brand new bike from the ground up in probably less than 6 months.
What's it like being able to ride for a team and a company that has such, like quick prototyping and building, like no other bike manufacturer can really do that so easily?
Yeah, it is pretty incredible actually. I've started to really use that to my advantage recently.
Okay.
I've always been sort of set and forget, but I've sort of realised now that everyone's moving forward and everyone's trying to make the next step. So, I mean, with having these guys, we can do so much stuff so quick, turn it around like rapidly. So, yeah, the last year I've really used that to my advantage, I think, and especially with this bike, trying new bits is going to be, it's going to be good.
Yeah. I think everyone kind of wants to know, like, what's it like to ride, both in terms of sort of like it being a downhill bike, a new one to you, but also, the pinion system in there, the Gates carbon drive, what's it like?
It's incredible. Yeah, I've been absolutely loving it recently.
I mean, you're paid to say that, but...
Yeah, I'm paid to say that, but yeah. No, it's really, really good. I think the best way for me to describe it would be... Oh no, get him out of it. The best way to describe it for me would be like going from a trail bike to a downhill bike.
Right.
It feels like I'm going to a downhill bike to like this super downhill bike. I think the thing is probably best about it is the confidence it gives you.
Yeah.
The bike is absolutely glued to the floor, and with the addition of the mid pivot as well, it just eats the bumps, tracks the ground so well. So yeah, it's a bit of an animal.
I guess you've got a lot of weight low and central in the bike compared to, none of this stuff flapping around down here, unsprung weight and all that sort of jazz. It's going to be pretty,
Exactly, yeah. I think the weight, some people think weight's a bad thing, but when it's in the right place, it's definitely not a bad thing.
Right, okay.
Yeah.
And what's the system like? It's an electronically controlled gearbox?
So yeah, electronic shifting, which is a bit of it seems like a bit of a party trick at the minute. When you shift, everyone's like, what is that thing? Yeah. So it does feel like it's like quite revolutionary. And
what's the advantage of that though?
For me, it's actually a bit harder to get used to than I thought. But you can shift wherever you want, and you don't need to pedal to change the actual gear. So for like a downhill race, obviously you don't pedal loads, but when you do pedal, you've got a very short window, so you need to make sure you're in the right gear. So I think having this system is very, very helpful. Mm-hmm. I can be thinking, okay, in 3 corners, I know there's a short straight, I've got to be in the right gear. I can shift in midair, not have to pedal. I know as soon as I pedal, I'll be in that gear. So that is, definitely a big help.
So for 2025, you're kicking off with Hardline Australia in a couple of weeks' time, and then there's obviously the full World Cup sort of circuit. Gates have announced this €100,000 prize pot for the first person to win a UCI Elite downhill race on their carbon drive. Is that a bit of a motivator for this year?
Well, I guess we're downhill racers and we're professional athletes. We always want to win. Obviously, that is a nice little sweetener, and it would obviously be really nice to win it.
Which track do you think this bike's going to work best on? Is it like steep, rough ones, or more bike parky ones?
I thought that. We rode I thought on the flatter tracks it wouldn't be so great, but we've been riding obviously a lot of W Bike Park, and even on the flatter tracks, I think with the additional weight and the way the suspension platform works, it carries speed so well. So this seems really good everywhere so far. But I can't wait to get it out on more tracks.
I mean, obviously, it's a really cool bike. I think everyone's seen a few sort of sneak peeks here and there, and everyone's really stoked for it. So I'm sure everyone in the comments, and of course everyone at MBUK, is really excited to see you racing it this year. So best of luck for the 2025 season, and go get it, man.
Thank you very much. Yeah, super stoked, and can't wait to get it to the races.